All right, so for this section, we're going to talk about proportions. So what is a proportion? Proportion is an equation that states that two ratios are equal. So these are, I know we're using letters and you guys hate using letters with math, but if a problem such as A over B equals C over D, so they're two different numbers, but we're saying they're equal. We use these a lot in math when we're talking about scales and sizes and things of that nature. But we can also use proportions to solve a lot of geometry type skills that we might be coming up with in the future. So one way to solve for proportions is by cross multiplying. We've talked about how to clear a fraction if we multiply everything in the equation by the common denominator, and one way we've found by a common denominator is to multiply by all the denominators together. So if there's just two ratios or two fractions that are equal to each other, we can use this method of cross multiplication. So when we talk about cross multiplication, we can say A times D and B times C, and we set those equal to each other, and then we solve for possibly or whatever the unknown variable. That's also a way for us to tell whether they're equal or not too, because if we have two proportions, so if I give you an example like 1 over 2, we know that, let's just say 2 over 4, an easy one, that these are equal in value. And how would I know that? I can cross multiply. So 1 times 4 equals 4, and 2 times 2 equals 4. So if given two ratios or two fractions, and we're saying they're equal to each other, we can always check to see if they're equal by doing that method of cross multiplication. All right, so let's say we have one unknown part, and this is going to lead to what we're going to get into with solving for ratios and unit rates we did the other day, and it's just going to be a useful skill to have. So let's say we have an original problem. We're trying to figure out what is proportionate to 4 over 7 that has that denominator of 12. Well, we use our skills of cross multiplication, so we can do 7 times x, which is how I came up with this one, and 12 times 4, which is right here. All right, so this is just the example of the setup on how we do that. So we have 7x equals 12 times 4, which is 48. So 7x equals 48, which I put here. And then just to solve for that x, we divide by 7. All right, and then when we do 48 divided by 7, we get this 6.86 or whatever it is. So if I do that over here, 48 divided by 7, and I just rounded to the 6 because it keeps going on forever. So that's basically how you solve for proportions if you have an unknown missing. And it doesn't matter where the unknown is in the problem, you're setting it up equal to each other when you cross multiply. So go ahead and try A and B. All right, I'm going to cross. I'm going to say 12 times x, which would be 12x, and set that equal to 4 times 25. Use your calculator if you need to. 4 times 25, that gives us, of course, 100. And now we're just solving for x here. So how do I undo this? I divide by 12. So x equals 100 divided by 12, which gives us 8.3 repeating. And that would be my solution there. Over here, I could cross multiply, and again, it doesn't matter if you do the y times 5 or the 7 times 24 first. Either way, whatever you do when you cross multiply, you're just setting them equal to each other. So I'm going to do the 7 times 24 equals 168 equals 5y, and then we divide by 5. Divide that by 5 gives us 33.6 equals y. So again, this is similar to how if we were to clear these fractions like we worked on in the past, a common denominator of 7 and 5 would be 35. If I multiply both of these by 35, all right, so I would do 35 times 24 divided by 5. That divided by 5, that gives me 168 equals 35 times y divided by 7. So again, 35 divided by 7 gives me 5y. So you can see how we took the notion of clearing fractions, that concept, and this is just a quick way to do it when you're only dealing with two of the fractions. All right, so now getting into the when we would use this, we can set up proportions when we're trying to figure out some other types of problems. So for example, in problem C, it says in an airplane you can fly 245 miles in 6 hours. How many miles can you travel in 2 hours? Well, there's a couple ways we can do this. We can figure out the unit rate, which we've done before, right? We can say we flew 245 miles, and I'm going to put the unit there just so you can see, in 6 hours. So we want to set up a proportion to figure out how far we will travel in 2 hours. So we don't know the miles, so I'm just going to put a variable in for there. So x miles, but we know we're trying to get it in 2 hours. So one way we could do this is to find the unit rate and then multiply it by 2, because the unit rate is how many we can travel in 1 hour. But the other way is to do this, because sometimes the numbers don't work out that nice and neat, or you're not trying to find the unit rate of 1, they're mixing it up on you. Excuse me. So this is a way that you can set it up to solve for that if you're going to look for the hours. The unit rate for this would be 245 divided by 6. We know that would be 40.833 miles per hour. We can multiply that by 2 and get our answers. Or we could set it up this. I want you to get in the habit of setting up these proportions because it will help you out. So if I look at this and I cross multiply, I have my 6 hours in the x here, so I can call this 6x. 245 times 2. That equals 490. And then I can divide that by 6 to get my answer. So x divided by 6 gives me the 81.6 repeating, or 0.67, whatever you want to do. So if you can go 245 miles in 6 hours, in 2 hours you'll be able to travel 81.6 miles based on that unit rate. So again, when we're setting up proportions, just make sure your units are on the same side and you'll be able to get that answer accurately. All right, so for example D, it says Alex can finish 6 math problems in 7 minutes. At this rate, how many problems can he finish in 22 minutes? So again, if we put our math problems on top and our minutes on the bottom, so 6 math problems in 7 minutes, set that up equal to, and we're looking for how many problems, so I'll put like a little p here, so we have a p for problems and minutes, so you can see where the actual units are. So we're looking for at how many problems, that's our unknown, so we can use that as x. Can he finish in 22 minutes? So that would go on the bottom there. And then we set up our cross multiplication, so 7 times x, 6 times 22, that gives us 132. And then, of course, we divide by 7 to get x by itself. So we can finish how many problems? So I'm dividing this by 7. 18.85. So at that rate of 6 math problems in 7 minutes and 22 minutes, should be able to finish 18.85. So almost 19 problems. All right, so the setup on these are pretty crucial, but once you get the setup, hopefully that cross multiplying is pretty straightforward.